we have already seen from my previous videos that the inverse of a square is a square root, which means that the inverse of a square root is a square. So, which means if we are performing an inverse operation whereby we have a square root on one side, all that we have to do is to square the other side to be able to undo that operation. So in example 1a, one which involves solving the equation, we are required to solve for x, which means to solve for x, we need to get rid of the square root. Now, the inverse of square rooting is squaring, so which means basically what we can do is we can square each side to undo the square root. So what we shall end up with is 16 is equal to x minus 3. And then our goal is to find x, which means we need to get rid of the minus 3. So we add 3 on each side. And what we shall end up with is 19 is equal to x. And that will be our solution. Why? Because negative 3 plus 3 is 0. So x is equal to 19. We can apply the same method or same process to the right hand side to rearrange this equation. So we can start by squaring. And what we shall end up with is t squared is equals to x minus n. The opposite of subtracting n is adding n. So we add n on each side. And what we shall be left with is t squared plus n is equals to x, because negative n plus n will be equal to 0. And that will be our final solution. We can apply the same processes to these examples. So example 2, solve for x. The first step is to get rid of the square root, which means we can square each side. And what we'll be left with is 25 is equal to 6x minus 7. Then we want to solve for x. We want to find x. So what we can do is add 7 on each side. Negative 7 plus 7 is 0. So what you're left with is a simpler equation. 32 is equals to 6x. We can carry on to divide by 6 on each side because we want to find x, which means x will be equal to 32 divided by 6. Or we can simplify this equation to 16 over 3. Okay? We can simplify that equation to 16 over 3. Okay, we can apply the same process to the right. So the first step will be getting rid of the square root by squaring each side. What we shall end up with is h squared is equals to g h x minus k. The next step will be getting rid of the k. So we add k on each side to remove k from the right hand side. Negative k plus k is 0. So we are left with h squared plus k is equals to g h x. Now, GH is multiplied by x. It's a factor that's multiplied by x. But we want to be left with the x. We want to remove that factor. So what you're going to do is divide by GH. And we have to do the same thing on each side. So what we'll be left with is h squared plus k over gh is equals to x. Okay, and that will be our final solution. Example 3, rearrange to make x the subject. So the first step here is, although we want to be left with x on one side, there's something that has been added to the square root of nx. Let's start by getting rid of that. So subtract r on each side. R minus r will be equal to 0. So what you're left with is y minus r is equals to the square root of nx. Now, we can get rid of the square root by squaring each side. So basically, what we shall end up with is y minus r squared is equals to nx. And then we can see here that n is multiplied by x. The opposite of multiplying by n is dividing by n. So we divide by n on each side. N divided by n is 1. So basically we are left with x being equal to y minus r squared over n. Example 4, rearrange to make x the subject. Now here you have to know that the inverse of a cube root is a cube. So the inverse of a cube root is a cube. We are going to apply that here. And before you work out that, we need to get rid of the minus a here. So the opposite of adding a, subtracting a is adding a. So we add a on each side. So what we shall be left with is the cube root of x is equal to b plus a, because negative a plus a will be equal to 0. And then the next step is just cubing, because we want to undo the cube root. So you can cube each side. So the cube root, the cube of x cubed is just x, okay? Because the cube undoes the cube root. So what you end up with is x is equals to b plus a cubed. You can also think of it this way, all right? The opposite of cube rooting x is cubing the other side. So x is equals to b plus a cubed. Example 5, rearrange the formula to make x the subject. Now, by inspection, we can see that 2 pi is multiplied by the cube root of x. So the opposite of multiplying by 2 pi is dividing by 2 pi. So we divide each side by 2 pi. 2 pi divided by 2 pi is 1. So what we end up with is m over 2 pi is equals to the cube root of x. And then the opposite of cube root is cubing. So x will be equal to m over 2 pi to power 3. Example 6, rearrange the formula to make x this, the subject. Now, the first step is we need to get rid of the square root by squaring each side. So what we shall end up with is this squared is equals to 4x over pi. The opposite of dividing by pi is multiplying by pi, so we multiply each side by pi. Pi divided by pi is 1. So we are left with a simpler equation. We are left with pi d squared is equals to 4x. The opposite of multiplying by 4 is dividing by 4. So you divide by 4 on each side. 4 divided by 4 is 1. So our resulting solution will be pi d squared over 4 is equals to x. Example 7. Rearrange the formula to make x the subject. Now, the first step here is you can notice that 2 pi is multiplied by the square root of x over g. So let's start by dividing by 2 pi on each side. Divide by 2 pi there, divide by 2 pi here. 2 pi divided by 2 pi will be equal to 1. So we shall be left with t over 2 pi is equals to the square root of x over g. The next step is the opposite of square rooting this side is squaring the other side. So this will be equal to t over 2 pi squared. And then multiplied by g on each side. Multiplied by g here, multiplied by g there. G and g cancel. So basically x will be equal to g multiplied by t over 2 pi squared.